In this episode, we're setting up randomized respawning, but with a few caveats. Hey guys, today we're continuing and really completing the respawn logic that we started last episode. And with a lot of games you have a random respawn, but it's usually not totally random. Usually there are places in the level that you'll respawn to, like save points. But for us, I want it to be a little bit more random than that. So what I'm envisioning is that we're going to have multiple characters running around all shooting stuff at each other in the level. And the way it's going to work, upon every respawn, there's going to be a calculated series of points that the player could respawn, the character could respawn to. And it's going to pick the one that's the furthest away from any character. So there isn't going to be a respawn spot that straight up is safe, but it's going to be as safe as we can make it, considering that we want the gameplay to be non-stop action. And I figure after a death, it's also good practice to favor the character that just died in some way. And a simple mechanism that I came up with is, couldn't we just face the character upon respawning to whatever the closest gameplay ability pickup is? Just a couple net new concepts this episode. I think we even did add unique before to array, but I just wanted to emphasize that again, that makes sure that if we're going to add something to an array, that it's not already in the array. But the game state, that's really important because the game state tracks every single statistic, basically everything going on with the game as it is currently. And the game state, in our case, this episode, we're tracking every single character in the game so we can get their locations at any given time. So let's get to it. All right, so we're going to start by setting up a new function on a blueprint function library. And the reason that we're using a blueprint function library is we want this function for getting a random respawn location. We want that accessible from any blueprint. And creating it in a blueprint function library will just give us the maximum flexibility. So if we go back over to our blueprint function library folder, we're going to do this in general functions that we started a couple episodes back. And we're going to create a new function on this blueprint function library. So we're going to add function, and this is going to be get random respawn location. First thing is, let's make it a pure function. Compile and save that. And that's going to have one input, and the input is going to be our respawn radius. So how far away from some center point do we want to look at respawning the character? And that's going to be a float. So in our case for the island, it's going to be a center point of the island and then a radius outward. And if you're following this series, you already know from a few episodes back the center point of your island, because we did that for the tentacle cutscene episodes. But let me just show you quickly how to get that. So if we come over here to the center point, I just put a gameplay ability pickup there. It's basically this 4700, 4700, 2590. So that's my case, but it might be something different for you. So if we go back to that function, we're going to right click, we're going to make a vector, and the vector is going to be exactly that. So 4700, 4700, and 2590. So next we're going to take our respawn radius here and promote it to a local variable. I'm going to title this the local respawn radius. So local respawn radius. All right, so this make vector here, we're actually just going to use it as a reference, because what we need to do is we need to take that local respawn radius. I'm going to multiply it by -1, and this is going to serve as the lower bound for wherever we're going to spawn to. So -1, and we're going to do a random float in range. Random float in range. We've done this before, so we can copy the local respawn radius again. That's going to be our max. And then we take our x value here, and we're going to add that to this. So this is going to be 4700, because from here, this is going to make a vector. And the vector that we're going to make is precisely this, but it's centering around this. And the reason it's centering around it is because by default, this is 0 and then plus 4700. But let's say our respawn radius is 1000, right? So it could be as much as -1000 or 1000 and add it to that 4700 figure. And then we can copy that same exact thing for our y value. So whatever your y is here, plug it in here, and then connect this up. And we could just connect it up like this so we don't need two of them. Yeah, that'll work. And then for the z, so this is a little weird, but we're going to make this a really tall, really high number. So it's going to be 10,000. Because what this is going to do is it's going to do line traces straight down from this point to the ground. And we want to make sure it's always above the ground, even if there's a mountain there. So I'm just going to put that at 10,000. All right, so we got everything we need from this. We can delete out this make vector. And actually, I'm going to take all these. We're going to move it over. From this, we are going to do a line trace by channel. And that's going to be our starting point way up in the air. And then our ending point is going to be this. And we'll subtract 12,000 so that we go below sea level. So you want that line trace to make sure to be long enough to hit something. And I'm just going to set the draw debug to for duration. That way we'll be able to see the line straight down. All right, so I'm going to come over here to the right. We're going to do a return value branch just like that. And what I'm going to do is get the out hit in break hit result, and we're going to get the specific location that the hit occurred. So right here, but I'm going to add 50 to it, and that's just going to make sure it's above the ground. So Z is 50, and then collapse this. So if we do get a hit, if this is true, then we're going to add a return node, because what this pure function is going to return is, well, it could be a location, but I actually want it to return a transform. And the reason I want it to return a transform, that includes the location, rotation, and the scale, is just in case, well, we actually want to do this by the end of the episode. We want to rotate our character to face something. So that means we have to return the transform, which is both the location and the rotation. So the output here, plus sign, and we're going to call this the respawn transform. And it's going to be type transform. So from here, what I can do is I can just make transform and then connect this up here, just like this. Now for rotation, we'll just leave that blank for now. So compile and save. And then for the false here, what I'm going to do is we're also going to add a return node. We're going to take our make transform, copy and paste that, because this false is only going to occur if we don't hit the ground on visibility. If we don't hit something on visibility on the line trace down. But basically, if this is false, so if it doesn't hit something, then we want it to just respawn the character right at that center point. And that's going to be a good indicator that for whatever reason our line trace did not work, and we can connect this up. So we'll compile and save this, and now we need to hook this up. And first I'm going to do it on our adversary AI character. So for that we have to go over to our game mode that we started editing last episode. So BP third person game mode. And so for the non-player character died here, instead of the make transform being this, what we can do is we can right click and get random respawn location. And let's put in a respawn radius of something small to start, maybe like 500. Connect this up. So we'll compile and save this. And if we open up our third person character, I think we still have from last episode, let's go over to our event graph. We have B to get our adversary AI and then do damage. So that's exactly what we're going to do. And we have our AI character, I think, on the beach. Yep, he's over here. And I'm just going to move him close to the center. So we'll move him in, move him up, make sure he's above ground. And then we can right click, preferably somewhere on the top of the island here, right in the center, and play from here. And then B. And I think he died. We're going to see in a moment. We should see a line trace straight down in just a moment. Yep, there's one. There's another. And there he is. Boom. Now let's do one more test, which is let's increase that radius to, how about 10,000? So something like that. And for my island, I think a good radius is actually about 11,000. So that's what I'm going to do. 11,000. I think that's about the outer ring of the beach. So same thing. Play from here. B. Basically looks like he's falling off a cliff. But, and let's see where he respawns. Somewhere in 11. Yeah, so way. So actually, I don't know why it's doing two different line traces, but it's doing two. And then regardless, he is spawning there. So we're all set. So now let's set up that same line trace logic for our third person character. So that's going to be really easy. So let's open up our third person character. We've already got him open. And we have to go over to the destroy and respawn character function. We started this last episode. And instead of this make transform right here, we're going to do the same thing. Get random respawn location. I'm going to set the radius to 11,000 and connect it up just like this. Compile and save. And then back over to our event graph, because what I'm going to do, I'm just going to disconnect for B here, the get actor of class. I'm going to disconnect this here. Instead, we're going to get a reference to self, connect this up, connect up press, just like this. That should do it. Compile and save and test with ourselves. So right click, play from here. Give it just a second or two, B. And boom, there's our resurrection. But if you do this a second time, so after your respawn, do it a second time. So if you get a black screen like this, and then you escape out, we get a whole bunch of errors. And what's happening here is we got to do the same set delay change on our third person character that we did on our adversary AI character. So over in our event graph, so actually I'm going to scroll up, go all the way up here. So instead of 0.2 seconds, we're just going to do a delay until next tick. So this one right here, delete this out, this one down here, completed to there. And one other thing I found that reduced the frequency of errors upon respawn. Sometimes I still got errors and not sure why that is. So if you have any insight, please leave comments below. But the other thing that I found that did make a difference is if we come down here to death. So down here, event destroyed. So what I did is I took these two, the remove from parent for the HUD. If you get any HUD errors, we're going to put those first. That's going to be the first thing we do before we cast a game mode. So move these over and then move these up just a little bit. Connect this up here and connect this up there. So compile and save, and let's test again with multiple deaths on our third person character. And you want to give it a few seconds before your character dies, because that way it's a little bit more realistic. Something like this. All right, so now we're going to add a layer of complexity to this, and that is, could we track at any given moment in time where all the different characters are in the game world and then respawn or randomize a respawn somewhere that's away from all those characters? That's what I want to do. And initially I was thinking we'd track all the characters in the level on the level blueprint because we haven't yet done anything with level blueprints. But I looked at recommendations on this, and the recommendation is don't do it on level blueprint because you're going to have multiple levels in your game and you don't want to have to replicate that logic every single level blueprint. They recommended that the right place to do this is on the game state because the game state is for the entire game. It tracks all the characters, all the players of the game. It's the right place to track characters. So we're going to do it on the game state. And the way to do that is in the content drawer. So if we open up our third person game mode, I just want to show this. So if we go to class defaults, it has our game state class here, game state base. But if we try to get to that, so this folder here, there's just nothing there. So we have to create a brand new game state. And I'm just going to right click here, go to blueprints. We're going to do blueprint class. And if I search for game state base, and we can use that as our parent class, so we'll select that one. You would only use this one, game state. You see it says behaves like a multiplayer match-based game. If you're doing multiplayer, I guess you would use that. Not doing that in our case. So game state base, select, and I'm just going to call this my game state. Yeah, we'll go into that. So now that we got that open, let's go back to our third-person game mode, and let's actually switch out the game state class. So we're going to switch it out to my game state. So that's going to make sure that our game mode uses the new one. So compile and save, and then go back over to my game state, go into the event graph, and we can delete out event tick. We're not going to need that, but on event begin play, we are going to get all actors of class. And we don't want to do this constantly because get all actors of class is pretty expensive. But yeah, we can just do it at event begin play and should be totally fine. So we're going to choose BP third person character because all of our characters are under that third person character. And then from this, we're going to promote it to a variable. And we're going to title this is going to be our array of respawnable characters. So we'll compile and save this, and then let's go back to our general functions blueprint function library. We'll create another new function. This is going to be the get best random respawn location. So this one is going to contain the get random respawn location because this is going to get more than just one. So once again with this, we'll make it a pure function, and we're going to do another input, and this input is going to be number of possible locations. So this is how many actual line traces we want to do down, and that's going to be an integer. We're going to promote that to a local variable, and that's going to be very simply our local number of possible locations. And then directly underneath, we're going to get the game state. And from the game state, we can cast to my game state, or our game state, but we titled it my. So connect this up here. And then come over to the right, and as my game state, we can get our respawnable characters, get. And I'm going to promote this to a local variable here. And this is going to be our local. I'm just going to say local all characters. Connect this up here. Compile and save. So before we do a for loop that's going to get all the possible locations we could spawn to, we are first going to get the locations with another for loop of all the characters in the game world. But there's going to be those two things that we need to do, like we need to get all the locations of the characters, then we need to get all the spawn locations, and then we need to compare those two things. So really that's three things in sequence. So we're going to do a sequence. So from here, we'll do a sequence, and we're going to add a third pin as well, but only going to use the first two for now. And for the 0 pin, we're first going to get our local all characters. And for this, we're going to do a for each loop and connect up 0 to there. And I'll move these up a little bit, put in a reroute right above it. And then from this, from our array element for each of them, we're going to get our actor location. So each of our character locations. And the next thing I'm going to do is create another local variable. This is going to be our local character locations. And this is going to be a vector, but not just a regular vector. Right click and make it an array from our local character locations, dragging a reference to that, get. And we are going to set array element, and we're going to set it at, I'm going to move this down, connect up array index there, this right here. Because basically we're building this array of locations based on each of those actors' locations, and I can say size to fit. Compile and save. So now we have a list of all character locations. We have to get the list of all possible respawn locations because we're going to compare the two. But really we're getting the list of possible respawn transforms because that's what our first function is doing. And actually we're going to change the name of both these from location to transform by the end of the episode. So we're going to create another local variable. This is going to be the local possible respawn transforms. And this is also going to be an array, but it's going to be an array of transforms. And one more local variable. This is going to be the local respawn radius. And this is going to be a float, single float, not an array. And if we go back to the very beginning of this function, we're going to add an input for that. So that's going to be our respawn radius, because we're going to pass that into this function. So not integer, float. So I'm going to move these two nodes out just a little bit, and we're going to get our local respawn radius, set that, and connect this up here and this here, connect it up just like this, put in a little reroute. All right, so you'll see how this is coming together. I know it's looking a little bit complicated, but come back over here to sequence 1. So we got to get our local number of possible locations. So how many possible respawn locations are we going to have? This is how many loops we're doing. So from this, we do a for loop. Connect up one here, and actually all of these I'm going to move up just slightly so I can move these up. So down here what I'm going to do is get our local respawn radius, and then we're going to use our function right here, get random respawn location. Drag that in, connect this up, because we're going to get a random respawn location for each of the number of possible locations. And then we're going to get our local possible respawn transforms, get, and we are going to set array element for each one of those, and we're going to set it to this, and connect up index here, connect up this here. You guys are going to know loops really well by the end of this episode. Move these over. All right, to recap what we got so far. So we got a list of character locations, an array of character locations, which is just a list. It's a list of their locations at this exact moment in time. And then we also have a list of possible respawn transforms, which is basically the locations that we could potentially respawn to. And so in this third pin, the sequence 2 here, we got to compare the two, and we got to say, okay, get the locations from here, compare them to these locations, and whichever location is the furthest away from any of these locations, that's where we're going to respawn to. All right, so coming down here, we'll get our local possible respawn transforms, and then we'll do a for each loop from each of those. And this is a little tricky. We've got to split this array element here. We got to split the struct pin, because we need to compare locations to locations. So actually, I'm going to move this down, connect this up down here. And within this for each loop, we are doing another for each loop, which is our local character locations. So this, we're going to do a for each loop. So a loop within a loop. It's basically multiplication. So if we have 10 of these, it's doing 100. And we got to compare these two locations. So we got to compare this to this one right here. And let's get our distance. And actually, I decided I'm going to do distance 2D. I'm not going to measure the vertical z. Like, that's not going to factor into the distance. It's just across the XY plane. So that's the distance 2D vector here. And then we'll connect this one here, put in a reroute. And you might think the loop within a loop is going to be really performance intensive. Hasn't been my experience. As long as we're doing line traces and not sphere traces, unless we're doing thousands of these, I don't think it's going to break the bank in terms of performance. All right, so we're almost done with the local variables, but we do need another one. And this is going to be our local longest distance. And that's going to be a float. And we're going to track this as it's comparing our transforms to the locations. It's going to track, okay, which one is our longest distance? That's why we need this. So we have to say, okay, if this distance 2D is greater than our current local longest distance, so if it's greater than this, then we want to set the new local longest distance to be this. So we'll do a branch here, connect this up here, and actually I'm going to move the branch in a little bit, because if it is true, then we want to set this. So set and connect it up to the true, and then this is what we're setting it to. One more local variable. So this is going to be our best respawn location array index. And this is going to be an integer, because in addition to tracking the longest distance, we need to track which array element is the longest distance. And actually, it's not this array index here, it's this one over here, because what we really care about is which of these transforms are we going to use for respawning. So what we want to do is set our best location array index, only if this is true, and we're setting it to this one right here. So I'll put in a couple of reroutes. So if you've got all that, so that's attached to sequence 2 here, but we got to do something upon completion of this, and that's going to be a return node. We have to return something from this pure function, and what we're returning is if we get our local possible respawn transforms here, and what we want to do is get a copy at a specific point, but we need to actually return it. So the return node, we're going to do an output. We're going to call that output our best random respawn location. That is going to be a transform. Actually, I should set that to be, instead of location, let's set it now to be transform, and we'll connect this up here. And it's not going to be index 0, it's going to be this index, the best respawn location array index. We'll get that reference, get connected up here. Compile and save this. So let's test this now with our own character. So we're going to do this on BP third person character in the destroy and respawn character. So instead of this, what we're going to do is get best random respawn location. And we'll connect this up here. And let's do something that's pretty performance intensive, right? So let's do like 100 possible locations with a respawn radius of 11,000. So that's a lot, right? It's going to do 100 line traces down. It's going to try to find the best possible one, the furthest away from any other character. We've got our AI character running around, so it's a good test. But before we test, I realized I made 2 mistakes in the initial setup here. So the first one, the local number of possible locations. Should it be our first index or last index? Because as it stands, it's just going to do, well, 0 index. So that should be hooked up to the last index. And then the second one, and this is really, really easy to miss, make sure to hit size to fit here, because if you do not size to fit with setting array elements, it's not going to set anything because it has no space to fit those new array elements. So make sure to hit size to fit. And yeah, just go over every single connection that you've got here, compile and save. So let's go ahead and test. I recommend testing somewhere in the center of the island. And we can also watch our adversary AI character. So there he is over by the ocean. And if I respawn, it should be well far away from him. So we see all of our line traces, 100 of them. Performance was okay and spawned on the other side of the island. But when we escape out, we get this issue here. And what's going on here is that, let me actually go back into our blueprint function library. So this first part where we're loading all the characters and it's trying to get our actor location. So we're getting the error because that character, when he dies, that character gets destroyed, pending kill or garbage. So the way I'm going to address this is that when a character is spawned into the world, it's going to add to that array, and when they're killed, it's automatically going to remove them from that same array, the character array that we started on our game state. So let's go back to our game state, my game state. I'm going to delete out this right here. We're going to have nothing on event begin play. But we're going to keep the respawnable characters array right here. But then back in our third person character on event begin play. So we got to go over to our event graph, event begin play. And I'm going to scroll over to right before our player controller reference. So right about here, we're going to move all this over to the right. Make some space. And this is where we're going to get the game state on begin play. We're going to cast to my game state. If I could spell cast to my game state. Connect this up here, and as my game state, we're going to get our respawnable characters, and we are going to, from here, add unique. And this is where we're going to add only a single copy of this character, because if it's already part of respawnable characters, we don't need to add it again to the array. So just like that, and then from add unique, connect up here. And then I'm going to comment this. We're going to comment add self to the my game state respawnable characters as unique character. Compile and save here. So what I'll do is copy all this because we need to do the same thing on our adversary AI character. So over to AI, BP adversary AI character, over to the event graph, and on our adversary AI character event graph. So I'm just going to make some space right before controller reference, same sort of thing, paste that in, move it down, move it down, move it down, and connect it up. Connect this up here. Compile and save. And last but not least, when our character dies, either the AI character or our third person character, then we need to remove our character from this array. So it's not using their location for calculating respawning because they're dead. So for that, we can go over to third person character, and we already have a function for that we created last episode, destroy and respawn character. And that's being used by both our player character and our AI character. So at the front of this, we can make some space, and we could do the same sort of copy paste, delete out the comment here, and instead of add unique, what we can do is we can remove item and connect up self to it. Connect up this to here, and we will move them in, connect up this to this, this to this, disconnect this, move this down, connect this up, compile and save. Picked up a couple abilities, and then, boom. Over on the beach, that looks good. Let's give it a second or two, do it again. And over on the beach again. So, yep, it's calculating whichever of those locations is furthest away from all characters. So the only thing that I'm going to adjust slightly is back in our third person character on the event graph. Actually, it's our destroy and respawn character. It's over here. So instead of 100 locations, I don't think we need 100, maybe 25. You could set this to whatever you think is useful and compile and save that. And now on to our AI character. And for that, we actually do the respawning on our game mode. It's this right here. And one thing I found, just found this through some more testing, for the collision handling override, select this try to adjust location but always spawn. And that makes sure the AI character will always spawn. So I'm going to move out the possess a little bit, compile and save this. And then instead of get random respawn location here, what we're going to do is we're going to get the best of the best of the best. with honors and connect this up. And the respawn radius, again, 11,000. Number of possible locations, 25. Compile and save. And to test this, back in our BP third-person character, now over to our event graph. Come down to the B, get actor of class, connect this up, move self, disconnect, and connect this up here. Compile and save this. And one other thing, so I also had some issues on event begin play, this delay of 0.2 seconds. And instead, we're going to set the delay until next tick. And that should address it. And I think we are ready to test. So compile and save our BP adversary AI character. And for this, I recommend playing from the very top of the hill and maybe make the AI character a little bit closer. So right now he's over here on the beach, and I'm just going to move him in a little bit. And we got to kill him multiple times, make sure he respawns accurately each time. So 1. Yep, he's down. Let's look at all the line traces. And he's going to be way out in the distance, but we just got to see him. Yeah, there he is, running along the beach there. Try again. Poor guy, it's like a sniper rifle shot. There he is. We'll do it one more time just for funsies. Oh, where is my little... There he is. And he's running for the gameplay ability. All set. And no errors. All right, so now let's do this for a ton of AI characters. So just drag in like maybe 5 or 6 AIs. They're not going to respond properly to each other in the game world, but that's okay. What we want to test, basically get an actor of class, make sure that they die properly, and make sure that they each respawn properly. So we've got 5 or 6 now in the game world. And again, let's start on the top of the mountain and play. So they're each running, they're each going for gameplay abilities. That looks good. Okay, I got one. I think that's the one right there. One thing you'll find is it's not going to reset the target. Yeah, there he is. He's out there in the distance there. So it's not going to reset another one that you could hit B for until it actually respawns the first one. So, just give it about, 5 seconds after hitting B before hitting it again. And once you see the line traces, then you could hit B again and try it out again. And they're going to do weird things. If you put in a whole bunch of AIs, they're going to conglomerate, accumulate all together because they're going to run at each other because they're not in attack mode or anything. Yeah, stuff like that in the distance there. But just keep hitting B on occasion and just make sure you don't get any errors and that they're spawning in relatively reasonable locations all over the map. Yep, no errors. So now we will do the appropriate thing and remove all but one for now. And you could just search, make sure you got all of them. So I still have 2. One somewhere on the beach. Where is he? There he is, down there. Yep, down to 1. And we can save all. All right, so now let's work on that final game mechanic that I mentioned, which is when a character dies, let's give him a leg up once he respawns, which is let's make him face whatever the closest gameplay ability pickup actor is. And if you have other things in your game world that you want the character to actually look at to kind of give them an advantage, by all means, you could point them at that. And this function that we're going to create is going to allow you to point him at anything. So the first thing we got to do is we got to go back to our game state, because in the game state, we are going to get all actors of class. And this we can do here because the gameplay ability pickup actors, we're not destroying them when they're picked up. We're making them inert, and then we're going to have an episode coming up where we're repositioning them somewhere in the world. But because they're never being destroyed, we don't need to reset them every single time. So we could just say get all actors of class, get all actors of class, and the class is our gameplay ability, and not any of these, but pickup. And right click on this and promote to a variable. And we can right click on this and rename. It's going to be gameplay ability pickups, one word. Compile and save our game state. And then back over to general functions. General functions. We're going to create a new function, and this is going to be get rotation to closest pickup. And once again, a pure function. It's going to have one input. The input's going to be location. And this is going to be a vector. Compile and save that. Promote location to a local variable. So promote, and we can once again rename it local location. All right, gonna make some space here on the right. What we're gonna do is we're gonna get our game state to start, and we're gonna cast to my game state, cast to my game state, connect this up here, get our gameplay ability pickups from here, so gameplay ability pickups, and then from these we're gonna do a for each loop, connect up this to there, And from each of our gameplay ability pickups, we're going to get the actor location. And now we're going to get our local location. So this is what we're passing in. The first thing we need to do is we need to compare this to our current actor location. So we're going to get the distance. We're going to keep the 2D vector and connect this up, because this location is where our respawn's about to occur. And then this one is where each of the gameplay abilities in our pickups are. And then we need to create another local variable, promote to local variable from this. This is going to be our local closest distance. Connect this up here. And what I realized is that we have to set this number to be a high number when this function is initially called, because what we're doing is we're looking to see, okay, we want to get the lowest number, the lowest distance, basically the closest gameplay ability pickup. And so that means this is going to be set to 0 to start, which we're never going to be below because it's always going to be a positive number for distance. So what we need to do is we need to set, I guess I could just set the default value, but I'm just going to do that right from here. So we're going to set this to some high number like 20,000. And that way, the very first gameplay ability that we're checking over here, it's definitely going to be less than the local closest distance. Yeah, so before we set this, so I'm going to disconnect this. I'm going to move this over. We're first going to check to see, okay, is this number, this distance, is that less than our local closest distance? Because only if it's less than that, then we're going to set the local closest distance. So we're going to do a branch, connect up loop body to the branch, true to here. Hope this is making sense. Compile and save. And we also need to do the same thing we did with the other function. We need to save this array index as a local variable. So promote that to a local variable. And I'm going to right click on this. It's going to be our local closest pickup. We will move that into position, put in a couple of reroutes, compile and save this. And then once this is completed, we are going to do a return node. And to that return node, so first let me put in a reroute. And we need to make some space because what we're returning is a rotation. And that rotation is going to be looking at whatever our local location is, whatever our gameplay ability pickup location is at this local closest pickup array index. So the way that's going to work is we got to get our local closest pickup. And from this, well, we can get our gameplay ability pickups reference here. We could say get. And we're going to get a copy at that array index. Actually, I'm going to move this over a little bit because from here, we're going to get the actor location again. And we're going to get our local location. So this is where we're respawning to. And we're going to find the look at rotation. We've done this in previous episodes. So we're looking at wherever that gameplay ability pickup actor is. And there's our rotation. But remember, we're only rotating on a single axis. And that's the Z axis, right? Because that's going to determine, are we rotated this way or that way? So we want the other rotation factors to be 0. So we can split the struct pin, we can keep these 0, and we're only going to connect up Z to, we're going to do a make rotator. Yeah, this one right here. And these are going to stay 0, but we're going to hook up the Z. And then, so move this in, move this out. We're going to make a output. And this is going to be the look at rotation. And of course, it is going to be a rotator. And connect this up. Compile and save this. And so now we have to adapt this function. We have to actually use it. So we're going to start in the get random respawn location, because in this one as well, we're going to get our rotator. So from this location here, I could just drag out a pin and get rotation to closest pickup right there. And then from this, hook up this to there. And remember, we don't need to hook it up down here because this is only being used if, well, if our line trace doesn't hit anything. So compile and save this. And then we're also going to do it for the get best random respawn location here. So we got to come down to here. And from here, I'm going to move out the return node a little bit. I'm going to put in a reroute just so I can move it out. And from this get here, we need to split this struct pin. So we select that. I got to disconnect it first. So disconnect, split the struct pin. And from this location, we're going to get rotation to closest pickup. And I could split this struct pin over here. I always like bringing it back to a transform. So instead, we're just going to make a transform from that. And we're going to hook up the rotation here. We're going to hook up the location here and the scale just like that. And this reroute, move this up, move this slightly. 1, 2, 3, A, B, C, compile and save. All right, so our functions here are all set. Back to third person character. Let's do one more test on ourself. Always want to test it on ourself first. That's not really true. Sometimes I do tests on the AI character first, but okay, compile and save B, and we are ready to rock and roll with this test. So what should happen is it should respawn the furthest away from our AI character that it can, but it should automatically rotate our third person character in the direction of the closest gameplay ability pickup. So B, boom, and he's rotated where? Where's the closest? Yeah, I guess that is the closest, right? But let's try this one more time. So, and there we go. So I'm rotated in that one right there. Do you see that? Pinging the screen. Yep. And that pretty much brings us to the end of the episode, but let's do some cleanup. And really the cleanup I want to do is on general functions here. So the first thing is, you heard me say that we're going to rename these because what they're really getting is transform. So let's right click, rename, respawn, transform. And this one as well, random respawn transform. And the next thing is this particular function, it's pretty messy, or at least it's pretty complicated. It's actually pretty clean because we used a sequence node, but it's pretty complicated. So I like to at least comment what each of these sections are doing. So we'll comment the top one, and this top portion, what this does is gets all current character locations. And then for the second one, we'll comment this as well. And this is gets a number of possible respawn locations. And third one, comment. And this one, a little bit more complicated, gets the best possible respawn transform based on distance to other characters, preferring longest distance. And just move that out to encapsulate everything. And last but not least, this returns the best possible respawn transform, including rotating towards the closest gameplay ability pickup. Compile and save. So that concludes our episode for today. And in our next episode, we're going to do a really quick tutorial on how to use data tables and structs, because what I want to do in the subsequent episode, we're going to have a gameplay ability spawner so that our gameplay abilities can be spawned all over our level. So I hope to see you there next episode.